A compact disc player or CD player is a wonderful machine. It reads tiny, invisible bumps on a shiny disc and turns them into music story sounds. Think of it like a music box for the modern age. Instead of a metal drum with pins, it uses a beam of light to read a secret code. This code is stored on the CD. The player is a detective, a translator, an orchestra, all in one small box. It takes something we cannot see with our eyes and transforms it into something beautiful we can hear with our ears. The journey of how this magical box is created is just as fascinating as the music it plays, starting from simple materials and ending with a complex working device. Before a single note can be played, many different parts must be made. The journey begins with the part we see and touch first, the case. This is the body of the CD player, its protective shell. It is almost always made of a type of plastic called ABS plastic. This plastic starts its life as tiny beads, like small hard grains of rice. These beads are stored in huge bags, containers. The beads are poured into a giant funnel, which leads into a very hot machine. This machine is called an injection molding machine. It is like a giant, powerful glue gun that melts plastic instead of glue sticks. The heat inside melts the beads into a thick, gooey liquid. Once melted, it is ready to be shaped. The machine uses immense pressure to push or inject this liquid plastic into a special mold. A mold is a hollow metal block carved into the exact shape of the case. There is a top half and a bottom half. When the hot plastic is forced into this mold, it fills every single tiny corner and space. It is a very satisfying moment, as the empty space is instantly filled with the potential for a new object. After just a few moments, the two halves of the metal mold open up. Inside, a brand new, perfectly formed plastic case sits, still slightly warm. Small pins then push the case out of the mold, and it falls gently onto a conveyor belt. The most magical part of the CD player is the laser assembly. This is the eye of the machine, the part that actually reads the disc. Making it requires incredible precision. The process starts with a tiny electronic component called a laser diode. This is a very small chip, smaller than a grain of rice, that can produce a focused beam of light when electricity passes through it. These diodes are made in extremely clean factories called clean rooms. The air is filtered to remove even the smallest specks of dust. A single piece of dust could ruin the delicate laser. The laser diode itself is not enough. The beam of light it creates must be perfectly aimed and focused. To do this, the diode is placed into a small housing, along with several tiny lenses. These lenses are made of special glass or plastic. They're shaped to bend light in a very specific way. Assembling these parts is often done by robots whose movements are far steadier and more precise than a human hand. Each completed unit is carefully tested to make sure its beam is perfect before it moves on to the main assembly line. For the laser to read the disc must spin. It cannot just spin at any speed, it must spin at a very precise and changing speed. This important job belongs to the spindle motor. This motor is the spinning heart of the CD player. Making this small but powerful motor is a process of careful winding and assembly. It starts with a central piece of metal called a stator. The stator does not move. It is wrapped with very thin copper wire over and over again. A winding machine does this, turning the stator while feeding wire at high speed, creating tight coils. These copper coils are essential. When electricity flows through them, they become temporary magnets, electromagnets. The next part is the rotor, the part that will actually spin. The rotor has permanent magnets attached. Permanent magnets are always magnetic. Unlike the stator's electromagnets, the rotor fits around or inside the stator with a tiny gap. The magic happens when the electricity is turned on. Electromagnets push and pull the rotor's magnets, making it spin. On top of the spinning rotor, a small platform is attached. This is the spindle hub, the plate where the CD sits. Only motors that pass are sent to the assembly line, ready to become the spinning heart of a new music machine. Every machine needs a brain to control its actions, and in a CD player, that brain is the printed circuit board, or PCB. This is usually a green flat sheet or a blue flat sheet that's covered in a complex web of thin copper lines and so many small electronic components. The journey of the PCB starts with a simple board made of fiberglass. The board is covered on one side with a thin sheet of copper. It's the blank canvas for the brain. The circuit design, like a map of tiny roads, is printed onto the copper with protective ink. The board is dipped in a chemical bath that eats unprotected copper. After rinsing, only the copper roads traces remain. A satisfying reveal, plain copper becomes an intricate pattern. Those traces are the wiring of the CD player. They connect all the components so electricity and data can flow. Tiny holes are drilled into the board. These holes accept the legs of electronic components. Now a miniature city is built. The board moves down an assembly line where machines and people place components. A pick-and-place machine works on the line. A robotic arm with a small suction cup picks up parts, resistors, capacitors. The finished circuit board looks like a dense, tiny city, ready to think and control the CD player. With all the main parts created, the grand assembly can finally begin. This is where the individual pieces, the case, the circuit board, the laser, the motor, come together to become a single working machine. The process takes place on a long assembly line where each worker or robot has a specific task to perform. The journey starts with the bottom half of the plastic case. This empty shell is placed onto the conveyor belt, ready to be filled. It's like laying the foundation of a house before the walls and roof are added. The empty case holds the promise of the finished product. The first major part to be installed is often the main circuit board. The brain of the machine is carefully lowered into the case. It is designed to fit perfectly. There are small plastic posts inside the case, and the circuit board has holes that line up exactly with these posts. The worker or robot then secures the board in place with a few small screws. The satisfying sound of the small electric screwdriver whirring for a moment and then stopping signals that the brain is securely anchored. With the PCB in place, the case is no longer just an empty shell. It has its intelligence. Next, the mechanical parts are added. The spindle motor, the spinning heart of the player, is mounted onto the chassis. This is often a metal frame that will hold the entire disc reading mechanism. It is lowered into the case as one piece and clicks satisfyingly into place. The installation of the CD drive mechanism is one of the most crucial steps. This unit contains the spindle motor. This unit contains the laser assembly. Both sit on a single chassis, the functional core of the player. It is where the physical action of playing a disc happens. Workers handle this part with extra care. Laser optics are very sensitive to dust and bumps. The chassis is carefully lowered into the plastic case. The design is so precise it often just snaps into place, held by plastic clips, or secured with a few screws. Once seated, connections to the rest of the player are finalized. The ribbon cables from the previous step are now routed. These flat, flexible cables are carefully folded and tucked away, so they don't get pinched or tangled. They are the nerves of the machine, the PCB, the moving parts. A cable from the laser carries data back to the PCB for decoding. Another cable carries power and control to the motors. Now the tray mechanism is added. This part presents the disc to the player. In most players, it's a drawer that slides in and out. With internal mechanics in place, the player is almost complete. The final pieces click into place. The CD player is now filled with all its important internal components, but it is still open to the world. The time has come to close it up and give it its final appearance. The top half of the plastic case, which was made in the very beginning, is now brought to the assembly line. This top piece has the openings for the disc tray and the buttons. A worker carefully aligns the top case with the bottom case. They're designed to fit together perfectly, like two halves of a clamshell. With gentle pressure, the two halves are pushed together. Close up on plastic clips locking with audible clicks. Decorative starburst overlays emphasize each click as the edges snap shut. Once the main case is sealed, the final external parts are added. Buttons being fitted into their slots on the front panel. The buttons allow the user to play. The buttons allow the user to pause. The buttons allow the user to skip tracks. These buttons are often part of a small, separate circuit board that is screwed into place just behind the front of the case. The clear plastic window for the display screen is also snapped into place. The metal panel with the output jacks is screwed on. Close up, the sockets where you plug into an amplifier. The final touch is often the brand logo. The name of the company that made the player is printed or attached to the front of the case. The assembly is now complete. Section 9. The first song. Testing and packing. Before any CD player can be sent to a store, it must pass a final exam. This is the quality control stage where the machine is tested to make sure it works perfectly. The newly assembled player is taken to a testing station. A worker plugs it in and pushes the open button. The disc tray should slide out smoothly and quietly. The worker places a special test CD onto the tray. The disc has signals and music tracks to check every function of the player. The worker presses play. On a screen, the tester watches the read status. The laser must focus properly. The motor must spin at the correct speed. Test, play the first track. Test, play the last track. Audio outputs are measured to ensure sound is clear and free of noise. Only players that pass every test move on. It has played its first song. The machine is ready for its new home. Each player is wiped clean, placed into a protective bag, box sealed with tape, boxes stacked on pallets ready to ship. Inside each box is a magical machine waiting to be opened and to fill a room with the beautiful sound of music.